Hello and welcome to this video in which I'll be solving a CAT 2023 Slot 2 quant question. And this question belongs to the topic of geometry. If you have not tried this question, I'll give you a bit of time. You can read the question and try it out once. It's not a particularly easy question, but I won't call it a difficult question either. Why I don't call it a very easy question is because this requires a bit of work. Like you have to put your pen and paper and you have to start to solve. So a bit of writing, a bit of calculation is required. But the concepts required to solve this question are not something which is very complicated. This is doable inside the paper if you have time. So this is not, of course, the questions that you should be picking up immediately as soon as you look at the question. You should first try to look for shorter questions inside the paper. But once you have done solving all of the questions which are short, very easy and sitters, then you can, of course, come back to a question like this where you can spend a bit of time, about a minute and a half or 2.5 minutes of your time, and you can easily get to the answer of this question. So if you've read the question, you will realize that this question is talking about a rectangle and the length and the breadth of the rectangle are given. So let me draw the figure that will be required to solve this question. So this is a figure that you will be getting. So this rectangle ABCD, length of the rectangle is 9 centimeters, breadth of the rectangle is 6 centimeters. And P and Q are points on the side BC such that when we join AP and AQ, then we get three enclosed areas, ABP, APQ, and AQCD. And the question says that these three areas are in geometric progression. Geometric progression means that the ratio of the consecutive terms will be same. So ratio of triangle ABP's area by triangle APQ's area will be equal to ratio of triangle APQ's area by the quadrilateral AQCD's area. So a couple of things to understand about these three geometric areas is that triangle ABP is a right angle triangle, of course, which is right angled at B. Triangle APQ will be an obtuse angle triangle because clearly angle APQ is an obtuse angle. And AQCD is a quadrilateral that we call a trapezium. A trapezium is a quadrilateral in which exactly one pair of opposite sides are parallel, and the remaining two sides which are opposite to each other are not parallel to each other. Right? So these three shapes, areas are in geometric progression has been given, and we have also been told that area of AQCD is 4 times the area of triangle ABP. Now with this sense of understanding, let's look at the solution of this question. So what we can do is we can start by assuming triangle ABP's area to be X. Okay, so just taking the area to be equal to X. And of course, because triangle ABP is a right angle triangle, its area can be written as half into AB into BP, because we can consider BP as the base and AB as the height, as it's a right angle triangle. So AB is the height, BP is the base, half into base into height. So we can write its area as half into AB into BP, and we know the length of AB. So I'm going to be putting the length of AB as 9. So I get triangle ABP's area as 9 by 2 into BP. Next, let me also assume that the common ratio of the GP, which has been mentioned in the question, is R. So if this is true, then I can write triangle APQ's area as X into R, right? Because if common ratio is R, then the next term will be R times that of the previous term, because only then will I get the ratio of area of triangle APQ by area of triangle ABP is equal to R. So X into R will be the area of triangle APQ, and APQ's area can also be written in the form of half into base into height as half into AB into PQ. Why AB? Because still AB is the perpendicular distance of the vertex A from the base PQ. So AB will be the height for triangle APQ as well. Base of this triangle will be PQ. So half into AB into PQ, once again putting AB as 9, I get area of triangle APQ as 9 by 2 into PQ. And similarly, we can say that area of trapezium AQCD can be written as XR square, right? Because it should be R times the area of triangle APQ. And the formula for area for trapezium is that it is equal to mean of the sum of the parallel sides. So sum of the parallel sides in the trapezium AQCD is going to be QC plus AD. Mean of that will be QC plus AD by 2 multiplied by height. Height is the perpendicular distance between the parallel sides, which in this case is CD. So which means area of trapezium AQCD can be written as QC plus AD by 2 into CD. Okay. Now CD is also the length of the rectangle, which should be equal to 9. So I'm putting CD as 9. So I get 9 by 2 into QC plus AD, and AD is the breadth of this rectangle, which is equal to 6. So I can write this as QC plus 6. So I have area of trapezium AQCD as 9 by 2 into QC plus 6. Now with all these things in our hand, we can easily solve this question. Because next what we can say is that we can use this part of the data which has been given to us, that area of AQCD is 4 times the area of triangle ABP. So area of triangle ABP is X. So 4 into X will be equal to XR squared. So from here I can find the value of R as 2. So R, the common ratio of this geometric progression is 2. So if this is clear, then we can now find the ratio of the areas of triangle ABP by triangle APQ as 9 by 2 into PQ by 9 by 2 into BP. That will be equal to the common ratio 2. So PQ by BP will be equal to 2:1. So basically, I'm doing this by this. So I'm getting um, this by this. So I'm getting PQ by BP as 2:1. Similarly, when I do this divided by this, then I get QC plus 6 is to PQ is equal to 2:1. From here, the question is very simple to solve. All we need to do is assume the length of BP as y. So if I take BP as y, then from the first ratio, I can say if BP is y, then PQ will be twice of that. So PQ will be 2y. Right. Now what I'll do is I will take the second equation. Now taking the second equation, I can write QC plus 6 is to PQ. So PQ is 2y. So I can write QC plus 6 by 2y is equal to 2. Right. So now taking this equation, I can write QC as BC minus BP minus PQ, right, plus 6 and cross multiplying 2y to the other side is equal to 4y. Now, if I look at the expression which I have on the left hand side, the length of BC we know is 6, breadth of the rectangle, PQ is 2y, BP is y. So putting all these values in, I get 6 minus 2y minus y plus 6 is equal to 4y. And simplifying this, we will get the value of y as 12 by 7. So if y is 12 by 7, that means that BP, length of BP is 12 by 7. Length of PQ is twice of that, so 24 by 7. And length of QC will be 6 minus BP minus PQ. So 6 minus 36 by 7, which is equal to 6 by 7. So we have now the length of all three BP, PQ, and QC as 12 by 7, 24 by 7, and 6 by 7 respectively. So finding out the ratios, we'll get the answer as 12 is to 24 is to 6, which is nothing but 2 is to 4 is to 1. So option C will be the correct answer for this question. Hope the solution was clear. Thank you.